0 to 2. Okay, we'll give this a minute for other people to join. See if Nick pops in. Pretty much Nick and Mallory right now. If not, we'll get this started. This should be pretty short and simple. We're doing the same thing that we did on Friday. But we are going to just use geometry. This first problem I'm going to do the long way just to show you we can always do it the long way. But then we'll use geometry to just kind of help us out a little bit. All right, I'm going to go ahead and get this started. I think be the only group in here. So if we're going to do the integral from 0 to 2 of 3x plus 4 with respect to x, this is the long way, which works for everything. What we need to do is to integrate the problem. So we could get a, let's see, a 3x squared over 2, and then plus a 4x. Now we don't have to put a plus c since we are going to find the definite integral from 0 to 2. If you're wondering what my bandage is, on Friday I decided to sharpen my lawnmower blade, and I have 3 stitches now, so that's some fun time in the hospital. You know, the place you want to be during this time. Alright, so what we're going to do is to plug in 0. So if I plug in 2, I'd get a 3 times 2 squared over 2 plus 4 times 2. I'll find that answer, and then we'll subtract. We'll plug in 0, which would be 3 times 0 squared over 2 plus 4 times 0. Well, that's going to be 0. Let's see, what would be over here on this side? So that'd be 4 times 3 is 12, divided by 2 is 6, plus 8, right? Did I do that right? And that'd be 6 plus 8, 14. So 14. Okay. Now, this isn't the only way to solve a problem. What we can always do is just define the area underneath the curve. So I'm going to do this problem over again, but using geometry. So I'm going to graph out what this equation would look like. So we have 3x plus 4. All right, so that would be just your standard 1, 2, 3, 4. Your y-intercept would be at 4, and we're going to go over to 2. I'm just going to put over to 3 so I have some space here. And our slope is 3, so we go up 3 over 1. 1, 2, 3. Put a dot here, and then we go 1, 2, 3. Go up. Go 1, 2, 3. Or we'd have a line that goes like so. And we want to find the area underneath the curve from 0 to 2. It all in, but I'm going to highlight it. So you can see we have a nice like rectangle that we could break up into a couple shapes. This rectangle here, I'm sorry about the video. I need to change my router, so I'm going to try to do that later today. So if we were to graph this out nice and neat, we get a line like this. You can also do this on Desmos. That'd probably be nice, quick. You might have to look at your screen or draw it. So we're going to look at the area from 0 to 3. So here's 0, 3. Okay, I'm going to just break this shape up. We got a rectangle, a really skinny one here. It's 3 wide and 2 tall, so that have an area of 6. And then this triangle here is 3 wide, and how tall is it? Up 2, up 2, up 2, up 6. So 1/2 of 3 times 6. 3 times 6 is 18, divided by 2 is 9. We can add those two areas together, 9 plus 6. That should be an area of 15. I'm just going to double check that answer. Seems good. Also going to take a break. got 15. Okay, so let's show another reason why doing the geometry method is pretty nice. Because we could have equations like this next one here, the integral from -1 to 1 of 1 minus the absolute value of x with respect to x. Okay, so we don't know how to do the absolute value integral. We totally skipped it when it came to derivatives, and we're going to skip it when it comes to integrals, at least doing it the long way. But we can still graph out the equation and find the area underneath the curve. So if I were to graph this out, -1 to +1, and then 0, like, so if I pick points, like if I plug in 0, 1 minus absolute value of 0 is 0. If I plug in 1, 1 minus the absolute value of 1 is 0. If I plug in -1, it's still 0. And we end up getting a upside down triangle here. So here's the equation of the line. So if we want to find the area underneath the curve starting from -1 here all the way to +1, we basically want to find the area of this triangle. So the area of any triangle is 1/2 its base. Well, this base is 2 wide. And its height. Well, its height is only 1. So we got an area of 1/2 of 2 times 1, which is 1. And that's it. Double check that answer. Yep, we're doing good. All right, last question, and this is another example of a crazy integral that we wouldn't be able to do normally. Using the integral rule that we know, so we have to use geometry. We're going to do the integral from -7 to 7 of the square root of 49 minus x squared dx. So if you know this equation here, that equation is basically a circle equation, but it's just the positive version, so it's just the upper half of the circle. The one thing that's nice about this is we're going from -7 to 7, so this is going to be the perfect semicircle. That's over 7. 1, 2, 3, 4, 5, 6, 7. Over 7 this way. 1, 2, 3, 4, 5, 6, 7. And up 7. 1, 2, 3, 4, 5, 6, 7. And it's centered at 0, 0. So if we were to graph that, we get a nice semicircle. Well, any circle would be pi times r squared. But this is a semicircle, so we're going to do 1/2 that. The radius is the distance from the center to the edge, or any edge, which would be 7 here. So we got 1/2 pi times 7 squared. So if we wanted to be exact, it'd be what, 49 over 2 pi? But we're going to type in the decimal into the calculator. And so we got, I'm just going to type in the whole thing, 1/2 pi times 7 squared. We get 76.9690. And so that's what we're going to type into the, just double check that there, yeah. Just going to type that back into Canvas, 76.9690. Oh, hey, Bowie, how's it going? Okay. All right, so I'm going to end that video there. It's pretty simple. I'm going to change my router, and I'm going to have to figure out something else to do with my hand because that hurt. All right, we'll see you guys tomorrow. Have a great day. Stay safe. Bye.